Now, can you please tell me the last topic?
Yes, ma'am. Direct iodination.
Yes.
We did direct iodination.
Direct iodination. Okay, okay. So basically, we were discussing about the halogen exchange method, right? So there are three halogen exchange methods. So these all are the methods of preparation of haloalkenes. Haloalkenes की हम preparation कर रहे थे. So first method was Finkelstein reaction. This reaction is very, very important. Direct question can come. Okay, like what is Finkelstein reaction? Write down the mechanism and with example, right? So what is Finkelstein reaction? So when chloro or bromoalkanes are treated with sodium iodide, okay, in the presence of dry acetone, so it will give you a iodoalkanes. Okay, so Finkelstein reaction क्या होता है? It is a preparatory method or halogen exchange method to
Is
form to form iodoalkenes. Okay, it is the method in which we prepare the iodoalkene by the reaction of chloro or bromoalkane with sodium iodide in the presence of dry acid. Because it's a halogen exchange, so what you are supposed to do, just exchange the halogen. Okay, suppose this is your Rx. Okay, so X could be your either chlorine or bromine. So exchange this halogen group to this with this iodine. Okay, so iodine will be replaced by this halogen X atom and you will get Ri. You will get iodoalkanes over. Okay. Second, we discussed about the Swartz reaction. Swartz reaction क्या होता है? So it is the method in which we prepare the fluoroalkenes. Okay, it is the method of preparation of fluoroalkenes. And what are the reagent used in this reaction? So we use metal fluoride. Okay, metal fluoride like your silver fluoride or either mercuric fluoride. Okay, Hg2F2 or either AgF. Okay, so in this, by the Swartz reaction, we can prepare the fluoroalkenes. So Finkelstein reaction was the preparatory method for the iodoalkane and Swartz reaction किसके लिए था? Fluoroalkenes. Third reaction, third method of preparation of haloalkane. So this is again a halogen exchange method. Hunts-Dicker reaction. Hunts-Dicker reaction. Write down the heading. Now, what is Hunts-Dicker reaction? So by the Hunts-Dicker reaction, we can prepare the bromoalkane. Okay, Finkelstein reaction से क्या बनाते हैं हम? Iodoalkane. Swartz reaction means fluoroalkenes. Okay, and in this Hunts-Dicker reaction, it is the preparative method for bromoalkenes. Okay, alkyl bromide or bromoalkane you can say. So write down bromoalkanes. Bromoalkanes are prepared by refluxing by refluxing silver salts of acids with with bromine in carbon tetrachloride CCl in carbon tetrachloride. Okay, so what is Hunts-Dicker reaction? So bromoalkanes are prepared by refluxing. Now, what does this refluxing mean? So refluxing is a technique, so technique or process you can say, in which there will be a continuous cycle of evaporation and vaporization. Sorry, evaporation and condensation happens simultaneously. What happens in reflux? See, suppose this is a container. तो यहाँ पे boiling हो रही है. Suppose you just give the heat. Okay. So what happens here? When you heat this, so here the vapors, the liquid will convert into vapors, right? It means evaporation will be done. And after that, what happens when there will be a water, okay, reflux, यहाँ पे reflux technique होता है, right? We use the condenser over here, and what happens in the condenser? The water is being filled. Okay, so what happens? This when the vapors when this vapors has a lid. Okay, this यहाँ पे एक lid होता है. जब वो vapors जब उस lid से टकराते हैं, okay, when they so what happens over here? The condensation happens. The condensation happens. So what is reflux? Reflux is a process or a technique in which a continuous cycle of evaporation and condensation. Then evaporation, then condensation. Okay, so this cycle happens. So this process is known as refluxing. This technique is known as refluxing. And bromoalkanes are prepared by this process. Okay, refluxing silver salt of acid with bromine in carbon tetrachloride, CCl4. Got my point, Lubna and Kutsia?
Yes, ma'am. Yes, ma'am.
Okay, let's see the general reaction. So, general reaction is, so it's a silver salt of acid. So, silver salt of acid means RCOOAG. This is a silver salt of acid. Plus, when you reflux the silver salt of acid with bromine, so bromine Br2 in the presence of carbon tetrachloride. So what happens over here? What happens over here? From here, the CO2 will be released, carbon dioxide gas, plus your AgBr, 1R. See, there are two bromine, right? So one bromine will come and make a bond with the R group. Okay, one bromine will goes with R group, so it forms the your bromoalkanes. Plus carbon dioxide gas is released, and one bromine it makes bonds with the silver. It forms the AgBr. AgBr. Yeah. So these two, carbon dioxide and AgBr, are the byproducts, and the main product is your RBr, which is your bromoalkanes. That's how bromoalkanes are prepared by this method, Huns-Dicker reaction. Okay. So continuous यहाँ पे क्या होता है? Refluxing. So refluxing happens at a high temperature, 350 Kelvin. The temperature here is 350 Kelvin. So what happens? Reflux occur, continuous cycle of the evaporation, then condensation. Evaporation, then condensation. Okay. So by refluxing with silver salts of acid with bromine in carbon tetrachloride, so it will give you a corresponding bromoalkanes. That's the Huns-Dicker reaction. Is it clear?
Yes, ma'am. Yes, ma'am.
And any doubt in this? Okay. For example, write down one example. Suppose we have CH3 COO minus Ag plus. Okay, so you know very well metal पे क्या charge होता है? Positive charge, and this oxygen will have the negative charge, right? Now, when you react it with bromine in the presence of CCl4 at 350-degree temperature, Kelvin temperature, and you do the reflex process. So now tell me what will be the product in this case. CH3COO minus Ag plus, okay, silver salt plus Br2 plus CCl4. What will be the, which bromoalkane will be formed? Just try it.
CH3Br.
Yes, very good. Yeah, because here the R group is CH3. So CH3Br will be formed. Okay. Bromomethanes plus carbon dioxide plus AgBr. Yeah. Okay, write it down. Get it?
Yes, ma'am.
Okay, right on the next. Physical properties. Physical properties of haloalkanes and haloarenes. First physical property is dipole moment. Can anyone please tell me what do you mean by dipole moment? Dipole moment. Okay, it's represented by this symbol, nu. Okay, do you know what is dipole moment? Lubna, what is dipole moment, बच्चे?
Yes, ma'am.
What is dipole moment?
Charge within, charge within a molecule.
Okay, see, dipole moment measures the separation between the positive charge and the negative charge. And dipole moment in a molecule caused due to the difference in the electronegativity. If one atom is electropositive, so second should be a electronegative, just like in hydrogen and fluorine, HF. So fluorine is most electronegative, right? But the hydrogen is electropositive. So what is here the dipole moment? Dipole moment is basically the, suppose this is your positive charge. Okay, this is your positive charge plus Q plus, and this is a negative charge. Negative charge. Okay, so according to basically this dipole moment kya hota hai is the product of the charge, which is separated charge, multiplied by the distance between these two. So this is the distance. The distance is represented by r. Okay, so this is a positive charge, this is a negative charge, and between the distance between these two charges are r. So here the dipole moment is the product of the charge, separated charge, okay, multiplied by the r, okay, the distance between them. So this is a dipole moment. And dipole moment, how dipole moment occurs? Due to the electronegativity difference between the two atoms, right? So let's see. Suppose we have a carbon, because we are talking about the haloalkanes, the CX bond, this carbon and halogen bond. Okay, this is X is your halogen atom and this is your carbon, carbon of the alkyl group or either aryl group. So you know very well the halogen is more electronegative than the carbon, right? So there is a negativity difference. So due to the electronegativity difference, what happens is X is more electronegative. Electronegativity means क्या होती है? The tendency, electronegative atom. What is electronegative atom? The atom which has a tendency to pull the electron towards itself, right? So this halogen atom has a tendency to pull the electron from the carbon to itself, towards itself, right? अपनी तरफ क्या करेगा? Electrons को pull करेगा. So due to that this will acquire partial negative charge, right? Because यहाँ पे क्या होगा? Electron density will increase on the halogen atom. So here on the halogen atom it will acquire partial negative charge and this carbon will acquire partial positive charge. Okay, so that's the, okay, now see, as we have discussed, this is the Q multiplied by R. Okay, or R, or sometimes you can also write it D. What is D? So distance between the two charges. So that's the dipole moment. Now the question can come like this, like dipole moment. See, this is your, suppose this is your aliphatic, right? Basically, this is your haloalkane. Haloalkane. Okay, this is your aliphatic ring. Cyclic to have, but this is your aliphatic. You can see only single bond is present, right? And this is your aromatic. This is your haloarenes. This is your aromatic. halogen atom is attached here, right? Now the question कैसे आता है? Question can come, be down. Dipole moment, dipole moment of haloarenes, no, haloalkanes is is greater than the haloarenes. Haloarenes. Okay, give reason. Give reason. Okay, so dipole moment of haloalkanes is greater than the haloarenes. What is the reason behind that? Okay, so reason could be, you can see over here. See, so in the haloalkane, this is a haloalkane. So in haloalkanes, you can write down, this is a haloalkanes. This is a haloarene. Haloarene. Okay. So you can see this halogen atom is attached here to the sp3 hybridized carbon, right? This is sp3 hybridized carbon. So this halogen atom is attached to this carbon, and this carbon is sp3 hybridized. And you know very well the sp3 carbon is less electronegative as compared to the sp2, right? So in this case, haloarenes के case में क्या है? See, this halogen atom is attached to this carbon. And what is the hybridization of this carbon? Utsia, what is the hybridization of this carbon? Yes?
Yes, ma'am.
It's sp2, right? Hybridization of this carbon is sp2, right? So in the haloarenes, the halogen atom is attached to this carbon, and this carbon hybridization is sp2. And the electronegativity of sp2 carbon is greater than the electronegativity of sp3. Just remember that, right? So this one is less electronegative. ये क्या है? Less electronegative, and this carbon is more electronegative. More electronegative. Okay. Now see, if this carbon is more electronegative. So what happens over here? The change in the, because this you know very well the halogen is again a electronegative element, right? And this carbon sp2 hybridized carbon is more electronegative. दोनों ही electronegative है. So the difference between the change in electronegativity decreases. Electronegativity difference यहाँ पे जो होगा, it will decrease. Why it decrease? Because here the halogen atom tries to pull electron towards itself because it's a electronegative element, and this carbon is sp2 hybridized. So due to the sp2 hybridization, it is more electronegative as compared to the sp3 hybridized carbon. तो ये भी क्या करेगा? अपनी तरफ इलेक्ट्रॉन डेंसिटी को पुल करने की कोशिश करेगा, राइट? So due to that, the difference in the electronegativity will decrease. Overall, difference in the electronegativity will decrease. But here, in the case of haloalkane, see, this is less electronegative, this carbon is less electronegative, and this halogen is more electronegative, right? So what happens here? The electronegativity will be increase. The change in electronegativity will increase, right? So due to the change in electronegativity increase हो रही है, due to that, the dipole moment of haloalkane is greater than the haloarenes. Is greater than the haloarenes. Yeah.
Yes,
Here
ma'am. Yes, ma'am.
you can write on the reason. Question can come directly, a type question like dipole moment of haloalkanes is greater than haloarenes. Write the reason. Okay. So what could be the reason? The carbon, the CH bond, write down the CH bond in haloarenes has, yeah, one more thing. See, because this halogen has a lone pair, right? This halogen has a lone pair. So it will donate its lone pair to the benzene ring. And due to that, benzene ring is show the resonance. Show the resonance. Okay, and here the electron will shift on the either ortho position or the para position. The electron density will increase. Okay, so it will, when it donate its electron to this carbon, what happens? There will be a partial double bond. Okay, and due to the partial double bond character between the carbon and X, okay, this carbon and halogen of this haloarenes, this bond will be very difficult to break. This CX bond will be very difficult to break, right? So that could be a reason also. Second reason could be this. So the CX bond in haloarenes has partial double bond character. Partial double double bond character. Why? Due to the resonance. Due to the due to resonance, which makes the bond, which makes the bond length bond length shorter, shorter, right? And why? Because you can see again, let's understand this. So in the haloarenes, this carbon and X bond has a partial double bond character, and this double bond character is very difficult to break because there will be a very strong bond between the carbon and X, between the halogen. So if the bond is very strong, so the distance between the two charges, like your plus charge, this carbon has a positive charge and this has a negative charge. So two charges के बीच का difference will be less. Okay, the bond length will be short as compared to the haloalkane. And you know very well the dipole moment depends on the charges, okay, separated charges, as well as the distance between the two charges. Okay, less the distance, less will be dipole moment. More the distance, more will be a dipole moment, right? So in the case of haloalkanes, you can see over here, in the case of haloalkanes, this carbon is sp3 hybridized. This is more electronegative, sorry, less electronegative, and this one is more electronegative. So this, suppose this is a carbon, this is a carbon, and this is a halogen. Okay, these two bond ki baat ho rahi hai. So this halogen is more electronegative, so it just tries to pull all the electrons towards itself. अगर वो खुद की तरफ electron pull कर रहा है, तो what will happen? The bond length automatically increases, right? Because the X halogen atom is more electronegative and the carbon is less electronegative, right? Due to the sp3 hybridization. So this halogen will try to pull all the electron towards itself because it's more electronegative, right? So what will happen if it tries to pull all the electron towards itself? So automatically the bond length, okay, the distance between the two charges, plus charge and the minus charge, will automatically increase, right? If it automatically increases, bond length increases, bond length become larger, okay? And if bond length become larger, so dipole moment also become greater, right? So that's why the, see, here you can see the dipole moment is directly proportional to the distance between the two charges, okay? So due to that, the dipole moment of haloalkanes is greater as compared to the haloarenes. Is it clear now, Utsi and Lubna?
Yes,
Yes.
ma'am.
Yeah, so two reasons, just keep this in your mind. First reason, due to the partial double bond character of the haloarenes. Okay, so the bond length becomes shorter in the haloarenes. And the second point, write down, the CX bond, the carbon and halogen bond in haloarene, haloarene is sp2 hybridized. Is sp2 hybridized, which is, and the sp2 hybridized carbon is more electronegative, which is more electronegative than sp3. Hence the polarity of CX carbon and halogen bond in haloarene is lower. And if the polarity is lower, it means the dipole moment is also lower. Okay, dipole moment भी उसका कम है as compared to the haloalkene. Okay, and the polarity is caused due to the electronegativity difference. More the electronegativity difference between the two atoms, more will be the polar. Okay, that molecule will be more polar if the polarity is more. Okay, if the polarity means the difference in the electronegativity is more. Okay, so you can write that's why this cyclohexane, it has greater dipole moment than and written Lubna and Qudsiya.
Yes, ma'am.
Okay. Next physical property is boiling point. Boiling point. Now write down. So haloalkane, since haloalkanes are polar. They are haloalkanes क्या होते हैं? They are polar in nature. Polar. So their boiling point is greater than parent hydrocarbon chain. Parent hydrocarbon chain. So the boiling point is higher, also higher due to larger molecular mass. Okay, now see this point. So haloalkenes, because we are comparing the haloalkenes and the parent chain hydrocarbon. Okay, because hydrocarbon, suppose we just take this hydrocarbon chain CH4, right? And what I told you in the first class, what is haloalkenes? When you replace this one hydrogen, okay, and when you replace this one hydrogen from the hydrocarbon chain, this is a hydrocarbon, only carbon and hydrogen is there, right? So this is a hydrocarbon. So when you replace this one hydrogen by the halogen atom, okay, when you attach this halogen atom, so this is your haloalkene. Okay, so when you compare this methane and the CH3Cl, okay, the boiling point of these two, so the boiling point of this CH3Cl will be more, CH3Cl will be more as compared to the hydrocarbon chain. The parent chain was hydrocarbon. Okay, so आपने one hydrogen को क्या किया? Replace from the chlorine group, chlorine or any halogen group. Okay, so due to that, because here you can see the chlorine and this bond, this carbon and Cl bond. Okay, so due to the difference in the electronegativity, this bond is more polar. This bond is more polar because you can see halogen is more electronegative and this carbon is positive. So this chlorine will attain the partial negative charge and this will attain the partial positive charge. And what is polar molecule? In which there is a difference between the electronegativity. Okay, electronegativity difference hoga, so that type of molecule is known as polar. So this haloalkanes is polar, so their boiling point is greater than the parent hydrocarbon chain. And boiling point also depends on the molar masses. Okay, more the molecular masses, more will be the boiling. So when you compare these two, this is your CH4, right? CH4, and this is your CH3Cl. Okay, so chlorine has 35.5. What's the atomic mass of chlorine? 35.5 plus 12 for carbon plus 3. Okay, so when you compare the molar masses of these two, like CH3Cl and CH4, so you will get to know that this CH3Cl has greater molecular mass as compared to this hydrocarbon. Okay, so that's why the boiling point of haloalkane is more as compared to the hydrocarbon chain. Okay, hydrocarbon with the same number of carbon. Okay, you ऐसा ना हो कि आप compare कर रहे हो. Suppose you just take the C5H12 and here you are taking CH3Cl. Okay, so you have to, the number of carbon should be same. The number of carbon should be same. If you are taking one carbon over here, CH3Cl, so you will take CH4. So between these two, you will compare, and between these two, because it depends on the number of molecular, larger the molecular mass or the number of carbon. So obviously, the haloalkane will have the more boiling point as compared to the hydrocarbon, only hydrocarbon. Okay, we will discuss it in details and we will do some questions. Okay, so do you get my point? Why haloalkanes are have more boiling point as compared to the hydrocarbon chain? So
Yes,
guess it
ma'am.
here. Okay. So after that, you can write this Rx, which is a haloalkanes have more boiling point than your RH. So RH is a hydrocarbon. Now, next point, for a given halogen, for a given halogen atom, boiling point is directly proportional to the number of carbon atoms. Okay, so if the halogen atom in all the molecule is same, okay, so if the halogen atom is same, then the boiling point is directly proportional to the number of carbon atoms. Okay, so the condition is halogen atom should be same. अगर एक molecule में chlorine है, so in second molecule it should be chlorine also, not iodine, right? Because you know iodine has a more molecular mass as compared to the chlorine, right? Chlorine or any bromine. So that's why for a same halogen atom, the boiling point is directly proportional to the number of carbon atoms. Suppose so CH3X, right? So then this is a C halogen atom should be same. If you are taking chlorine over here, so सब में chlorine होना चाहिए. So CH3 CH2X. Next is your CH3 CH2 CH2 X, and the next is your CH3 CH2 whole thrice and X. Okay. Now arrange this on increasing order of the boiling. Okay. So between these four molecules, which one had the more boiling point, higher boiling point, and which one had the least boiling point? Suppose this is your A, this is your B, C, and D. Tell me.
B has highest boiling point.
Yes, very good. Right, because boiling point is directly proportional to the number of carbon atoms. And here the number of carbon atom is 3 plus 1, 4. 4 carbon. Okay, after that, this. Okay, this CH3, 3 carbon chain. After that, 2 carbon chain. After that, this CH3X. Right? So it depends on the number of carbon mole atoms. But the condition here is the halogen atom should be same. Third point, for a given alkyl group. Now, if the alkyl group is same, if the R group or alkyl group is same, so for a given alkyl group, boiling point is directly proportional to the molar mass of halogen. Yeah. Another point is again very important. Now here, the halogen atom is different. Okay, halogen atom is different, but the alkyl group is same. And if the alkyl group is same and different halogen atoms are present in different compound, So boiling point is directly proportional to the molar mass of halogen. Okay, molar mass of halogen atom. For example, suppose we have RF. So R group is fixed, right? RF hai, then RCl. Okay, then your alkyl bromide, then your alkyl iodine. Okay, now tell me which one have the highest boiling point and which one have the least. Yes, molar mass of halogen atom, directly proportional.
Ri has highest.
Ri. Ri will have the highest molecular mass. Iodine will have the highest molecular mass, right? So boiling point depends on the molar mass of halogen atom, right? So Ri का सबसे highest होगा, right? And Rf will have the least. So that's the order. That's the order of the boiling point. So alkyl iodide will have the highest boiling point, and your alkyl fluoride. Okay, alkyl fluoride will have the least boiling point. Got my point?
Yes, ma'am.
Yes, ma'am.
Okay. Examples you can write. Suppose we just take CH3, CH2. Okay, ethyl fluoride will have the least, then this. Okay, so you can see over here the alkyl group is same, CH3, CH2. CH3, CH2. Ethyl group is present, okay, in all the molecules. But the halogen group is different. So the boiling point, if the halogen group is different and the alkyl group is same, so boiling point will be directly proportional to the molar mass of halogen. Okay, so iodine will have highest molar mass, सबसे ज़्यादा होता है. So that's why it has the highest boiling. Yeah. Third point, write down. Boiling point is inversely proportional to branching. Branching. Okay, if you see the branching in a molecule, so the boiling point is inversely proportional to branching. If more the branching, less will be boiling. More the branching, less will be the boiling point, and vice versa. For example, if we suppose 1, 2, 3, 4, 5, let's take this molecule. Suppose this is your A, this is your B, and this is your C. Now tell me which one have the least and which one have the highest boiling among these three. See, its boiling point is inversely proportional to branching. More the branching, less will be boiling.
He has the least boiling point.
Which one have the least? C.
Yes, ma'am.
Yes, C will have the least. Why? Because here you can see more branching. And A will have the most boiling point. Okay, because it's a straight chain, there is no branching. Right? So that's the order. A will have the highest boiling point, then your B, then your C. C will have the least boiling. Okay, write down one question here. Arrange the each set of compounds in order of increasing boiling points. Boiling points. Question number 1 is bromo, methane. Second is bromoform. Third is chloromethane. And the fourth one is dibromomethane. First question. Then the second question is 1-chloropropane. Second is your isopropyl chloride. Third is your 1-chlorobutane. Okay, just quickly do this question. You have to arrange these in order of increasing boiling points. First, draw the structure, analyze the points, which we have discussed, and after that, arrange this in increasing order. Bromomethane. Draw the structure. It's methane, right? So CH3, Br, then bromoform, just like a chloroform. CHCl3, similarly, it's a bromoform. So it means CHBr3. Third, chloromethane. Okay, chloromethane. So CH3Cl. And here the dibromomethane. Dibromomethane means is CH2Br. CH2Br. Now arrange these. So you can see here all alkyl group is same. Okay, alkyl group in all the four molecule is same, right? So it depends on the molecular mass of the halogen atom, right? Now see in three, like first, suppose this is your A, this is your A, B, C, D. Okay. Now in three options like A, B, and D, there are bromine atoms. Okay, bromine, and in the C part there is a chlorine. Okay, and you know very well fluorine, chlorine, bromine, iodine. Okay, so bromine has more mass than chlorine. Okay, so यहाँ पे क्या करो? Just CH3Cl, so it will have the least. It will have the least boiling point, right? Because when the alkyl group is same, the boiling point is directly proportional to the molecular mass of halogen atom, right? And you know when fluorine, this sequence, fluorine, chlorine, bromine, iodine, right? So bromine का क्या होता है? This atomic mass of bromine is higher as compared to the chlorine, right? So these three atoms, three molecules has A, B, and D options have the bromine. Okay, only C option has chlorine. So chlorine will have the least boiling point. Okay. After that, now between these three, which one will have the boiling point after CH3Cl? Yes, Lubna.
Yes, ma'am.
Which one? A, B, or D? Which option? Yes, Lubna, tell me the answer. B? No. C? Let's see how to analyze this type of question. See, so first, why this has the least boiling point? Understood or not? CH3Cl have the least boiling point. What's the reason?
Ma'am.
Got the point? Hutsia?
Yes, ma'am.
Yeah, because these three options has a bromine. Bromine, bromine 3, bromine, and here two atoms of bromine. But in this option, chlorine was there. Chlorine was the halogen atom. And we know that the bromine, between the chlorine and bromine, which one has the higher molecular mass? So obviously, bromine has a greater molecular mass as compared to the chlorine. Okay, so that's why this has the least boiling point because iska mass, molecular mass of chlorine is lower than that of bromine. Now between these three options A, B, and D, you know alkyl group is same, so it will depend on this bromine. Okay, on this halogen atom. Now see here, only one bromine is there. Only one atom of bromine is attached to the Smith alkyl group. And here three bromine. Three bromine means more masses. Okay, three bromine means suppose one bromine ka mass hai kuch, right? So there are three bromine, right? Three bromine is present, so it will have the highest boiling point. More the number of molecular masses of the halogen atom, more will be the boiling point, right? So here the three halogen atoms, three bromine is there. So CHBr3 will have the highest boiling point. After that, after B, what will be the order? 2 bromine, right? CH2Br2, CH2Br2. And after this, one bromine atom, CH3Br. That's the order. That's the order of the boiling. Got my point?
Yes, ma'am.
Lubna? Okay, so this one is B, then D, then C, then your A, then C. Okay, what about the second one? Tell me the order of boiling point in the second question.
1-chlorobutane has the highest boiling point.
Which one have?
1-chlorobutane.
1-chlorobutane. Yeah, good. Yeah, 1-chlorobutane will have the highest boiling point. First, let's draw this structure. 1-chloropropane. So it's 1, 2, 3. Okay, 3 and there 4. Next, this is your isopropyl chloride. So here branching again, right? Isopropyl chloride 1, 2, 3. This is your iso and the chlorine. Then this is your 1, 2, 3, 1, 2, 3, and 4 and the chlorine. Yeah. Now see, this is the case in which the halogen atom is same, right? So it depends on the number of carbon atom. Number of carbon atom in the alkyl chain. Okay, so between this, suppose this is your A, this is your B, this is your C. Okay, so see A and between the C, A and between C, the number of carbon in C is more. 1, 2, 3, 4 carbon. And here the 3 carbon is there, right? So obviously the carbon, this will have the more boiling point. C. Okay, सबसे पहले C हो गया. After this, between the A and B, between A and B, which one will have the boiling point after C? Yes, Lubna?
Mm.
A, right? Why A? Because you can see here's no branching. In A there is no branching, but in the B there is a branching, and you know very well boiling point is inversely proportional to branching. Okay, so you have a branching zyada, it means it will have the low boiling point. So that's why C, then A, then B. That's the order of boiling point. Is this point clear?
Yes, ma'am.
Okay, Kutsia?
Yes, ma'am.
Okay. Now let's see. Third one is your melting point. Third physical property is melting point. Okay. So melting point, write down. Melting point depends on two factors. Two factors. First one is your intermolecular force of attraction. Intermolecular force of attraction, which is directly proportional to dipole moment. More the dipole moment, more will be the intermolecular force of attraction and more will be the melting point. Okay, so if the dipole moment is more, okay, dipole moment is more, so what happens? The intermolecular force of attraction between the molecule will be more. Okay, and if the force of attraction is more, then it will be compactly packed. Okay, compactly packed, and the force of attraction between the atom is more strong. So it will be the melting point of that molecule will be high. Okay, so melting point will be high. Second is the packing. Second factor is the packing. Crystal packing. कैसी packing है? If the packing of the that molecule is symmetrical. Okay, suppose write down symmetrical structures. If the structure of the molecule is symmetrical, so they have better packing. They have better packing. लैटिस की हम क्रिस्टल सॉलिड की पैकिंग की बात हो रही है यहाँ पे, राइट? So what happens? Suppose we just take a symmetrical or unsymmetrical. This is your okay benzene ring, and here the chlorine is attached, and here other chlorine is attached. Okay, so this is a dichlorobenzene. Okay, and again, so this chlorine is attached to the ortho position. Sorry, para position. Okay, this is your para position. This is your chlorine. And when you compare this chlorine, so this is your ortho, this is your meta, and this is your para position. So other chlorine is attached to the para position, right? So what happens here? Due to the symmetrical, you can see this is a symmetrical structure, right? So when you cut this from here, so it is a symmetrical. यहाँ भी एक chlorine है, इस side पे है, and this structure is a symmetrical structure. So what happens here? Here the dipole, see, the net dipole moment is zero due to the symmetrical structure. Here the net dipole moment is zero. Means if the net dipole moment is zero, means this molecule is non-polar, right? It is non-polar molecule. Now, in the case of when the chlorine is attached to the either ortho or meta position, so this chlorine, okay, and if it is attached to the meta position, and the second case may if it is attached to the this ortho position, right? So here you can see these two are not a symmetrical type. It's an asymmetrical type of a structure, right? These two are a asymmetrical type of a structure. So what happens? This chlorine will give you a dipole moment, right? And another dipole moment. Okay, so basically, first case में क्या होता? Net dipole moment. These two dipole moment will cancel it out. Okay, ये cancel हो जा रहा था these two due to the symmetrical structure. But here you will get some. The net dipole moment should not be zero. यहाँ पे zero नहीं होगा. And similarly, in the case of ortho, this one, the net dipole moment, basically, the net dipole moment will not be equals to zero. So when the net dipole moment is not zero, so these molecules are polar. These molecules are polar. Okay, so that's why the boiling point of of and you know very well intermolecular force of attraction is directly proportional to dipole moment. Okay, and dipole moment is means polar molecules में dipole moment क्या होंगे? ज्यादा होंगे. Okay, in polar molecules the dipole moment is more. So more the dipole moment, more will be the intermolecular force of attraction. Okay, and if intermolecular force of attraction is more, it means the melting point of that molecule will be high, right? Melting point will be high. So that's why melting point or boiling point also you can write both, right? Melting point or boiling point के case में भी same ही होता है. Melting point of ortho and meta, ortho and meta compounds is greater than the para one. Is greater than the para. Yeah, clear? Why in sometimes questions कैसे आएंगे? Why in meta dichlorobenzene or para dichlorobenzene the melting point is high. The melting point of ortho or meta dichlorobenzene is quite high as compared to the ये melting point of the para dichlorobenzene. Okay, so that's the reason, because in para dichlorobenzene the net, because due to the symmetrical structure, what happens? The net dipole moment it becomes zero, and if the net dipole moment is zero, it means that molecule is non-polar. Okay, So, and the intermolecular force of attraction in the non-polar molecule is quite uh, less, right? Quite less. So, due to that, melting point is less. Melting point is ki kam hoti hai as compared to the ortho and meta. In the case of ortho and meta, you can see here the net dipole moment is not equals to zero. Kuch net dipole moment hoga because these two won't cancel each other. Okay, these two dipole moment won't cancel each other, so that's why you get some dipole moment. And if dipole moment is present, it means these two molecules are polar. Okay, and if it is polar, it means the intermolecular force of attraction between in these molecule is quite high, and due to the high intermolecular force of attraction, the melting point of these molecules is quite high as compared to the para structure. Okay, is it clear, Lubna, Kutsia?
Yes, ma'am.
Okay, please write it down. After that, you can add this point. Due to symmetrical structure of para dichlorobenzene, it fits it fits in packing. Okay, so, solid packing, crystal packing. So due to the symmetrical structure of para dichlorobenzene, it fits in the packing efficiently, and hence the melting point is lower. Just a second. Okay, next one is your solubility. Solubility. Yeah. So if we talk about the solubility of haloalkanes, what happens? The haloalkanes are immiscible in water. Okay, now the question is, does haloalkane are polar? Okay, but why these are immiscible in water? Okay, that's an important question. So see what happens over here. The suppose this is your water, this is your water molecule. Okay, and you know very well there is a hydrogen bonding. Okay, the oxygen, okay, the oxygen of this water, it makes bond with the electropositive because this is a partial negative. This has a oxygen has a partial negative charge, and this hydrogen has a partial positive charge. This is the water molecule H2O. Okay, so another H2O will come and make bonds with this water. Okay, this oxygen again has a negative charge and this has a positive charge. So ये oxygen इसके साथ bond बना लेगा. This is known as hydrogen bonding, right? Now again, this oxygen has a negative charge, so this will make bond with this hydrogen. Okay, that's how the bond formation occurs in water. Now what happens? What happens when the alkyl group? Suppose this is your H2O, water molecule. You are trying to dissolve the haloalkane in the water, right? So alkyl, this haloalkane, you know, this is your Rx. Okay, this is your Rx, and you know very well this because this hydrogen has a positive charge. Okay, the water hydrogen, and this has a negative charge. Again, this has a positive charge. And when we talk about the haloalkane, so you know very well the halogen atom will have the partial negative charge due to the most electronegative nature, and this will have the partial positive charge. Okay, so when haloalkane came and tried to make bond with the this hydrogen, okay, this hydrogen and this hydrogen. So you can see over here there is a bulky group which is attached to the halogen atom, R group, right? So R group is attached here. So what happens? What happens? Write down when this RX bond is dissolved in water. ये जो RX है, this when you try to dissolve in water, so there will be a new attraction came into play between the water, okay, and RX. And this new force of attraction between the water and RX, this H2 and RX, is much weaker than the hydrogen bonding, right? Than the hydrogen bonding. So due to that, the RX is immiscible in water. Okay, RX is immiscible in water. यहाँ पे hydrogen bonding नहीं होती, एक new force of attraction होता है between the RX and the water molecule. And this new force of attraction is quite weaker as compared to the hydrogen bonding of the water molecules. Okay, because hydrogen, see, this is a hydrogen bonding in the water molecules. See, this H2O. H2O is the formula of water, right? And this hydrogen is attached to this oxygen, right? The most electronegative is attached to the most electropositive element, right? So this oxygen will acquire negative charge, and ये जो negative oxygen है, it will try to make bond with the other uh, positive part of the other water, okay, other water molecule. So this oxygen and hydrogen, again this hydrogen and oxygen, this oxygen hydrogen. So this type of bond formation you will see in the water molecules, which is the hydrogen bond. But when you try to dissolve the haloalkane in the water, what happens is haloalkane, it tries to, ये oxygen के साथ bond नहीं बनाएगा, because you know very well this again has a negative charge, and this oxygen will have the negative charge, right? So if it try to approach this oxygen, so here it will feel the repulsion because both have the negative charge, right? So it will try to make bond with the hydrogen. ये हाइड्रोजन के साथ बॉन्ड बनाने की कोशिश करेगा. That and this bond, this new force of attraction between this hydrogen and the halogen atom comes into play, and this is much weaker than the hydrogen bonding. Okay, hydrogen bonding of the water molecules. So due to that, this is immiscible in, sorry. So haloalkanes are immiscible in water due to this reason. Any doubt in this, Kutsia and Lubna?
No, ma'am.
If there is any doubt, you can ask. Don't hesitate, bache. Lubna, clear?
Goodness again.
Okay. Okay, so write down this point. Haloalkanes are immiscible in water, even they are polar. Now, write down the reason. When alkyl halide is dissolved in water, new interactions come into play, between water and your alkyl halide. So this new force of attraction between water and alkyl halide is much weaker than hydrogen bonding, which is between water H2O molecules. Hence, Rx, Rx is immiscible in water, in water. Okay, but haloalkanes are miscible in organic solvent. Okay, organic solvents में they are miscible, they are soluble. Okay, please write it down and please update me after this.
Done, ma'am.
Okay.
Ma'am, can you
After
explain?
this, yes, this solubility, Lubna.
Yes, ma'am.
Okay. Okay, so let's see. Now, first understand what is hydrogen bonding. Right. So hydrogen bonding is basically so bonding which occurs with suppose this is a water molecules. Okay. So water molecules में पहले से ही hydrogen bonding is present. Right. So what happens in hydrogen bonding? This H2O. See, this is your water. The structure of water is H2O. Okay, H2O, two hydrogen and one water. So sorry, two hydrogen and one oxygen, right? So you can see the to the hydrogen there is a oxygen linked, okay, and oxygen is more electronegative, okay, than the hydrogen. Okay, it's a most electronegative elements. So here you can see there is a large difference between the electronegativity. Hydrogen, when you compare the electronegativity of hydrogen and oxygen, so there's a large difference. So what happens? This oxygen will acquire partial negative charge, and this hydrogen will acquire partial positive charge. These two, partial positive charge. Now, so there are lots of molecules of water present, right? So this oxygen, it tries to make bond with the hydrogen of the other water molecule, of the hydrogen of the other water molecule. So other water molecule, suppose this is again H2O. Okay, so this hydrogen will make bond with this oxygen. Why? Because this hydrogen is electropositive. इसके पास positive charge है and this will have the negative charge, so they can easily make bond with each other. So this is hydrogen bonding. When the most electronegative atom combines with the positive atom of the other. Okay, because you know very well there are two types of hydrogen bonding, intermolecular or intramolecular, right? Two types of hydrogen bonding is present. So that's why this oxygen will make hydrogen bonding with the other hydrogen, with the other molecule of water. Okay, so similarly, this oxygen will try to make bond, try to make approach this hydrogen, and it will make bond, hydrogen bond with this hydrogen. Similarly, other hydrogen, other water will come, water molecule will come, and this hydrogen will approach this oxygen. Okay, so ऐसे होता रहता है. This chain will occurs, and that's how the hydrogen bonding will form. Okay, and hydrogen bonding is quite uh, their attraction is quite strong as compared to other bonds. Okay, so this is a water molecule. So water molecules have again a hydrogen bonding between their molecules, but when you try to dissolve the haloalkenes, so haloalkane is a bulky. There is a bulky R group which is attached to the halogen, right? Now you know very well what's the nature of the bond. So this is RX bond, right? So you know very well this halogen is electronegative. Okay, and the alkyl group में जो carbon present है, this is electropositive, right? So when this bond will break, so this halogen will acquire partial negative charge and this will acquire partial positive charge. Okay, so now when this haloalkane will come, when you try to dissolve it in water. Okay, so what happens? Because this R group has a positive charge, right? So ये तो involve नहीं होगा in the bond formation. This will involve in the bond formation. But if it tries to approach this oxygen, okay, because इसके पास भी negative charge है and this is again have a negative charge. Both are electronegative. Okay, so uh, there will be the bond formation between these two is not possible. Why? Because both have a negative charge, right? They will repel each other. Okay, जब ये एक दूसरे के साथ approach करना चाहेंगे, what will happen? They will feel repulsion. There will be repulsion. Yeah, Lubna?
Yes, ma'am.
Yes. So what happens over here? So it has another option because it can make bond with the positive one. जिसके पास positive charge है, right? So this hydrogen has a positive charge, so it will make bond with this. Okay. Now this bond is not a hydrogen bonding. This is a new interaction. You can call it as a new force of interaction. Okay. So when haloalkanes came, so new force of attraction between the hydrogen and the this halogen of the alkyl. Okay, halogen of the haloalkane group. तो यहाँ पे न्यू बॉन्ड का फॉर्मेशन होगा बट दिस न्यू बॉन्ड इज वीक बॉन्ड एज कंपेयर टू द हाइड्रोजन बॉन्डिंग जो वाटर में पहले से हाइड्रोजन बॉन्डिंग प्रेजेंट है दैट वाज वेरी स्ट्रांग एज कंपेयर टू दिस बॉन्ड so the new bond formation between this halogen and the hydrogen is very weak, okay, is very weak. So due to that force of attraction between the water and the Rx is much weak, so the hydrogen bonding between the see, so further molecule will come, further H2 molecule will come and try to make bond with the oxygen, okay, this oxygen and this hydrogen, okay. तो ये क्या होगा? This bond will break, okay. Basically ये bond formation होगा ही नहीं. This will be immiscible, okay. Proper miscible नहीं होंगे water के साथ. This will be insoluble. Okay, due to the weaker bond formation. See, what happens? What happens when the bond is more strong, then it will survive. Then it will survive. If the bond is very weak, what happens? Other bond will comes into play, and if it is more strong, तो वो bond को क्या करेगा? Break कर देगा. So that's why this haloalkanes is not miscible in water, but it is miscible with other organic solvents, right? So that's the reason due to the weak bond formation, due to the weak intermolecular force of attraction between the halogen and the hydrogen atom, the bond is very weak. So that ये क्या होगा? ये break हो जाएगा and you can't mix the haloalkane into the water. So that's why it is immiscible in water.
Yes,
Now
ma'am.
is it clear? Any
Yes,
doubt?
ma'am. No, ma'am.
Okay, so I think we should stop here. In the next class, inshallah, we will start with the methods of manufacture